In this video, we will see how to write the structure of a compound or formula of a compound if its IUPAC name is given. Writing formula of a compound when IUPAC name is given. So, you will be given the IUPAC name, you have to write the formula of the compound. So, first, a coordination compound means we have a coordination entity and a counter ion, or a complex part and a counter ion part. And in the complex part, when you write the formula, we write the symbol of the central atom first, followed by the symbol of the ligands in alphabetical order. So, symbol of metal, after that ligands in alphabetical order. So, this is how we write the formula of a coordination compound when IUPAC name is given. Now, we will do few examples. First question, tetraamine aqua chlorido cobalt 3 chloride. Now, if you look in this, you know that you are given the ligand's name. Tetraamine means 4 ammonia, aqua H2O 1, chlorido 1 chlorine, cobalt 3 chloride. So, here you know the oxidation number of the metal atom. The metal atom is cobalt with oxidation number 3 plus 3 and the counter ion is chloride. So, let us see how to write the structure or formula of the coordination compound when its IUPAC name is given. First, you have to write the coordination entity which has the central atom and the ligands. So, the central atom is cobalt, we will write the symbol of cobalt first, followed by the ligands in alphabetical order. Now, here it is given in alphabetical order. So, amine, aqua, chlorido. Tetraamine means NH3 4 times, aqua H2O, chlorido Cl. Now, no more ligand. So, the coordination entity is over. Now, the counter ion is chloride. So, I will write Cl outside the square bracket. Now, I should know how many chloride ions are there. When you see the word chloride, we will just write Cl. But I told you we will not write the prefix in the IUPAC name of the counter ion. So, here we had to find out how many chloride ions are there. For that, you should find the charge on the complex ion. To find the charge, you know the oxidation number of cobalt plus 3. So, how will you calculate the charge? That is, here we have plus 3, the charge of ligands 0, 0, minus 1. This complex ion charge you have to calculate. So, how will you find this x? X will be the sum of charges of central atom and ligand. So, how will you find out x is equal to plus 3 plus 0 minus 1, which is equal to plus 2. So, here you got x as equal to plus 2. X will be equal to plus 2. Now, I am going to write here plus 2. So, we know the charge of chloride ion is minus 1. So, here if it is plus 2, how many chloride ion we should have? 2 chloride ion. So, I should write Cl2, which means now we have chloride ion as minus 2 and the charge of the complex as plus 2. Now, the compound is neutral. So, we have here the charge. How many chloride ions are here? 2 chloride ions. So, this is the structure of the coordination compound. So, when you write the structure of the coordination compound, you have to find the charge of the complex ion and you have to neutralize the charge of the counter ion after that. Okay. Now, the second question is potassium tetracyanonickelate 3. Now, the central atom is nickel, potassium is the counter ion, tetracyano, ligand is cyanide, 4 cyanide group, and you can see here it is given as nickelate. Whenever you see 8 with the central atom, we can say that the complex ion is negative and the oxidation number of nickel is given plus 3. So, let us write the formula of the compound. Potassium is written as K. Now, start the square bracket. We have the central atom as nickel, Ni, tetracyano, so Cn 4 times. Now we have to find the charge on the complex ion, only then you can find how many potassium ions are required to neutralize that charge. So for that, nickel oxidation number is +3, cyanide ion is -1, this you don't know, so take it as X. Now find X, X will be equal to +3 minus 4, which will be equal to -1. So instead of X, I am going to write -1. So if this is -1, how many potassium should be there? 1, because we know the charge of potassium is +1. So what is the formula of the compound? KNiCN 4 times. So this is the formula of the compound. Okay, because we need only 1 potassium as the charge on complex is -1. Now next example is tetraamine diaqua cobalt 3 chloride. Now let's see the third question. The central atom is cobalt, so I am going to write, and the counter ion is chloride, so we will be writing it last. Let's write the coordination sphere, coordination entity cobalt CO. Tetraamine diaqua means tetraamine NH3 4 times, diaqua H2O twice. Now no more ligand, so I can close the square bracket, chloride Cl. Now the next step is to find the number of chloride ions. For that I should find the charge of complex ion. So cobalt +3 oxidation state, ammonia 0, water 0, this you don't know. So what will be X? X will be equal to +3. Now if this is +3, you know the charge of chloride ion is -1. How many chloride ions should be there? Cl3. So what's the formula of the compound? The formula of the compound is CONH3 4 times H2O twice Cl3. Now the fourth question is tris ethane 1,2-diamine chromium 3 chloride. So let's write tris ethane 1,2-diamine chromium 3 chloride. So chromium is our central atom. Let's start the square bracket, coordination entity. Now tris ethane 1,2-diamine. Ethane 1,2-diamine can be written like this. Tris means 3 times. Now no more ligands, but we have the counter ion as chloride. Now you have to find how many chloride ions are required. For that, chromium charge is given as +3. Here the charge is 0 and this is X. So what will be X here? +3 + 0 will be equal to X. X will be equal to +3. So here chloride ion charge is -1, which means to make it -3 we need 3 chloride ions. So what will be the formula of the compound? CrEn thrice Cl3. Now the next question is question number 5. Amine, bromido, chlorido, nitrito, N platinate 2. So the central atom here is platinum. So I'll be writing platinum. Now amine, bromido, chlorido, they are the ligand. So amine means NH3, bromido is Br, chlorido is Cl. All the ligands are same number, that is 111. Then nitrito, there is one more ligand, that is nitrito N. Nitrite group is NO2 and the linkage is through nitrogen. So how will you write NO2? If it is given as nitrito O, how will you write instead of NO2? You write it as ONO. Now here it is nitrito N, so you will write it as NO2. Now the ligands are over. Now we have no counter ion, it is just platinum 2. So you should find whether the compound is neutral or not. For that, find the complex ion charge. How will you find? Platinum is +2, ammonia 0, bromine -1, chlorine -1, nitrite ion is -1. So +2 +0 -1 -1 will be equal to X. X means charge on complex ion. So what is the value of this? It will be +2 -3, which is equal to -1. So I am going to remove this X and write here what? Minus. So this is the formula of the complex. So this is not a neutral complex. This is a ion and the charge is minus. Now next question is tetrabromido cuprate 2. Now tetrabromido cuprate, when you see cuprate, it shows that the complex ion is negative. Now I am going to write the formula. Cuprate is copper. Then we have tetrabromido, Br4, Cu, Br4. Then find the charge on the complex ion. Copper is +2, bromine is -1. So +2 -4 is equal to X. X will be equal to -2. So -2. So the formula of the compound will be CuBr4 2 minus. Now question number 7. Question number 7 is pentamine nitrito O cobalt 3. Now here the central atom is cobalt, so we are going to write CO. Pentamine means NH3 5 times. Nitrito O. So here we know that the linkage is through oxygen. So how will you write? It is written as ONO. Now no more ligands, so close the square bracket, and no counter ion is also given. So pentamine nitrito O cobalt 3. Now you should find out if there is any charge for the complex ion. So here we have cobalt, the oxidation number is +3, ammonia 0, ONO is -1. So this is equal to X. So what will be X? X will be equal to +3 -1, which is equal to +2. So how will you write the name charge? What will be X? It is +2. So you will write it as 2 plus. So this is the formula of the compound. Here you had to write the charge as 2 plus because no counter ion is given. Now question number 8 is potassium trioxylatochromate 3. Now here we have the central atom as chromium and potassium is the counter ion. Chromium, then trioxylato, so C2O4 thrice. And you should find out how many potassium is needed. For that, chromium oxidation number is +3, oxalate ion is -2. Find out what is X. So X will be equal to +3 -6, which will be equal to -3. So what will be X? I am going to replace that X as 3 minus, and you can see it's given as chromate. 8 shows that the charge is negative. Now here it is 3 minus, means potassium charge is +1. How many potassium I need? 3 potassium. So when you write the formula will be K3Cr C2O4 thrice. This is the formula of the complex. Okay, when you write the formula, the structure, no need to show the charge as and all. Okay, that charges are written just for us to understand. Now question number 9 is potassium tetrachlorido palladate 2. Now palladate is palladium, symbol is Pd. So the central atom is palladium and we have the counter ion as potassium. So K, now start the bracket, Pd, palladium. Tetrachlorido means Cl4. Now no more ligands. Now find out the number of potassium ions required. So that palladium is given +2, minus 1. So find out the charge on complex ion, that is X. What will be X? X will be equal to plus 2 minus 4, which is equal to minus 2. So replace this X with 2 minus. Now potassium charge is plus 1. So to make it neutral, 2 minus, I will need K2. So what's the formula of the compound? Formula is K2PdCl4. This is the formula of the compound. Now the last question is potassium trioxalato aluminate 3. Now here we have aluminium as the central atom and potassium as the counter ion. So K. Now aluminium is Al, trioxalato, so C2O4 tries. Now you have to find how many potassium ions are required. For that, aluminium is plus 3, oxalate ion is minus 2. Find the charge on complex. So X will be equal to plus 3 minus 6, which is equal to minus 3. And you can see it's given as 8, which shows that complex ion is negative. So I am going to rewrite this X as 3 minus. Now how many potassium will I need to neutralize 3 minus? 3 potassium. So what will be the formula of this compound? The formula is K3Al C2O4 thrice. And tell me what's the coordination number of this compound? Coordination number of this compound is 6. What do you mean by coordination number? The number of ligands. Since this is a didentate ligand, oxalate ion is a didentate ligand, I had to multiply with 2. So 3 into 2 will be equal to 6. So these are the examples for writing the structure of the coordination compound or formula of the coordination compound if IUPAC name is given. Thank you.